Today, we're going to be looking at how President Garfield proved the Pythagorean theorem by using area of triangles and area of trapezoids, and using the fact that the angles on a line add up to 180 degrees, and all three angles of a triangle add up to 180 degrees.
All right, now we're going to give some background information about James Garfield. James Garfield was the 20th president of the United States, but he's not taught much in history classes because he was only president for 3 months. But the reason he was only president for 3 months was that he was the second president that was assassinated after Abraham Lincoln. He was president only during the month or the year of 1881, and that was 16 years after Abraham Lincoln was assassinated. James Garfield was assassinated. Now, before he was president, he was a professor of classics, so ancient Greek and Latin, at a college in Ohio. And he was born into poverty there, and he worked his way through college by initially being a janitor and later being a professor at the college, and eventually becoming the dean of that college for a while. And then he went into the military and fought in the Civil War. And then after he fought in the Civil War, he came back. He taught a little bit. Then he became a politician. He decided to become a politician, and from there, he eventually got into the House as a House of Representatives. And it was while he was a representative in the a sitting member of the House of Representatives, that he discovered this proof we're going to give of the Pythagorean theorem. It was a new proof, and he generally knew. He was what's called a polymath, which means he was good in lots of different fields, so ancient languages, math, lots of different subjects. And that was while he was in Congress, and then he became president, and then he was assassinated. And his background is very interesting, but sadly quite brief as president, only 3 months. All right, now we're going to move from the background about him into the background for the proof. So the things required to prove the theorem.
Before we get into the proof, we quickly have to go over the concept of area. Area is defined as base multiplied by height for any given rectangle. We can easily derive the formula for the area of a triangle using a rectangle. If we cut a rectangle down its diagonal, we get two triangles. So the area for one of those triangles is going to be half the area of a rectangle, which is why the area of a triangle is 1/2 base times height. The area of a trapezoid is b1 plus b2 times h, all divided by 2, where b1 and b2 are the two bases which are parallel to each other, and h is the height. We can once again derive the area of a triangle by once again splitting this trapezoid into two triangles by cutting it down its diagonal.
We're going to describe how the area of a trapezoid and the area of a triangle are actually related. So the area of this trapezoid, that we'll call ABCD, is going to utilize the formula for the area of a triangle. So the overall area of this is going to be 1/2 times the height times b1 plus b2, where b1 and b2 are parallel to one another. So the way we can derive this is by looking at the area of triangle 1 and triangle 2. So the area of triangle 1 is going to be 1/2 base, triangle 1 has base b2, times the height, and the area of triangle 2 is going to be 1/2 times the base, which in this case is b1, times the height again. So if I want to find the area of this whole shape ABCD, I'm going to add the area of these two triangles. So I'm going to have 1/2 b2h plus 1/2 b1h. And if I factor out a 1/2 h that's in common, I get b1 plus b2, which is exactly this. Now we're going to look at Garfield's proof of the Pythagorean theorem. So in the picture that we have laid out here, we're going to assume that triangle 1 and triangle 2 are the same triangle. If you notice, the blue angles are the right angles are across from side C, making C the hypotenuse. In triangle 1, the green angle is across from side B, and in triangle 2, the green angle is also across from side B, They're in different places, but they're the same angle. Likewise, you can show that the red angle in triangle 2 and 1 is also the same angle. So the intuitive part here is to show that this angle here is going to be 90 degrees. Let's take a look at what we know about triangle 1 and triangle 2. So since they are the same triangle, we can make some angles equal to each other. We know that angle RPS, the angle in blue, is going to be equal to angle TWR. The angle in green in both triangles. In triangle 1, you have angle PRS being equal to, in triangle 2, WTR. And the red angle in triangle 1, we're going to have angle PSR is going to be equal in triangle 2 to angle TRW. Now, we know that angle RPS and TWR in triangle 1 and triangle 2 are both going to be 90 degrees by construction. Then we also know that angle PRS plus angle SRT plus angle TRW has to equal 180 degrees because these three angles all sit on a straight line and a straight line totals to 180 degrees. So we know that angle SPR is equal to 90 degrees. And we also know that angle TWR is equal to 90 degrees. This means that in triangle 1, angle RSP plus angle PRS has to be 90 degrees. Since angle SPR has already taken up 90 degrees, the other two have to add up to be 90 degrees to make 180 total. In triangle 2, angle WRT and angle RTW also have to add up to 90 degrees. We already know that angle RSP is the same angle as WRT, and we know that angle PRS is the same angle as RTW. So we know that the red angle and the green angle in both triangles are going to add up to 180 degrees. If you look closely, you'll notice that angle PRS plus angle WRT are also going to add up to be 90 degrees. So angle PRS plus angle WRT are going to add up to be 90 degrees. So now we know that we have 180 degrees as our straight line, which is going to be equal to angle PRS plus angle SRT plus angle TRW. But we know that angle PRS and WRT are already going to be 90 degrees, which leaves us with the conclusion that angle SRT is going to have to be 90 degrees, since this angle and this angle added together is going to be equal to 90 degrees. We already know that angle RSP is the same angle as WRT, and we know that angle PRS is the same angle as RTW. So we know that the red angle and the green angle in both triangles are going to add up to 180 degrees. If you look closely, you'll notice that angle PRS plus angle WRT are also going to add up to be 90 degrees. So angle PRS plus angle WRT are going to add up to be 90 degrees. So now we know that we have 180 degrees as our straight line, which is going to be equal to angle PRS plus angle SRT plus angle TRW. But we know that angle PRS and WRT are already going to be 90 degrees, which leaves us with the conclusion that angle SRT is going to have to be 90 degrees, since this angle and this angle added together is going to be equal to 90 degrees. We are now going to utilize the area of a trapezoid that we discussed earlier to come up with the Pythagorean theorem. So the area in general for a trapezoid, as previously discussed, is half of b1 plus b2 times the height. Now looking at the shape that we have here, our area is going to be 1/2. b1 in this case is going to be a plus b, and b2 is also going to be a plus b. Now, we know that this is going to be equal to half of a plus b squared. Also, the area is going to be equal to the sum of the areas of the three individual triangles inside of the figure. So we're going to use the formula for the area of a triangle to sum up the area of the total figure. We know that the area of a triangle is half base times height, so we also have that the area is equal to half of, in triangle 1, we're going to have base A and height B. In triangle 2, we're going to have half of base B times height A. And in triangle 3, the base and the height are going to be the same thing. And both of those are going to be equal to C. So we're going to have half of C times C. We're going to simplify this. And we're going to get C squared. Now, we can take out something in common between these two terms. We're going to take out an AB. It's going to leave us with 1/2 plus 1/2 plus 1/2 C squared, which is equal to AB. A half plus a half is just 1. So we're going to be left with AB plus 1/2 C squared. Now, we know that this area here is going to be equal to this area here. So we're going to set these two equal to each other. Okay, now we're going to go ahead and expand out the left-hand side. So a plus b squared, you can use the FOIL method to figure that out. First, outer, inner, last. So we're going to have a squared plus 2ab plus b squared. This 2ab is because when I multiply the outsides and the insides, I get ab plus ab, which is just equal to 2ab. So we have this, and we know that that is equal to ab plus 1/2 c squared from this previous equation. So I'm going to go ahead and distribute the 1/2. So I have 1/2 a squared plus 1/2 times 2 is just 1, so this becomes just ab. 1/2 b squared is equal to ab plus 1/2 c squared. Now I notice that ab is common between both sides, so I can cancel those out, and I get 1/2 a squared plus 1/2 b squared equals 1/2 c squared. I can divide everything by 1/2 on both sides of the equation. So I went ahead and I pulled out a 1/2 out of a squared and b squared to show you that it's common between them. And if I divide both sides by 1/2 or multiply by 2, whichever way you want to phrase it, then we get a squared plus b squared is equal to c squared, which is only the statement of the Pythagorean theorem.